This is Team Faceplant, and welcome to our progress report by Xander, Cindy, Justin, and Eric. Our project is divided into two parts. And the first part is question generation. During this part, the program takes in a Wikipedia article and an integer and needs to generate the number of questions according to this Wikipedia article. The first kind of question we're going to generate are binary questions. Binary question can be divided into two parts, yes or no questions or choice questions. These questions can be generated by looking for some simple predicate sentences. These sentences will be parsed into a part of speech tree. For example, the sentence, "The code is good," will be parsed into a tree like this. A simple question that can be generated with this technique is, for example, is the code good, by bringing the verb to the front of the sentence. To achieve this, we'll be using NLTK, Stanford parser, and maybe the offline function of text block. For more complicated questions like all the WH questions like what, where, who, we'll generate it with the following steps. Remove all the unnecessary negations in the sentence, map the verb to the question head. Use a bio tagger such as name entity recognition to find the question head and the subject, and replace the tag with all the WH question heads like what, where. Then we will restructure the sentence and post-process it so it's fluid and smooth. Consider the previous example, the code is good. These steps will generate questions such as what is good and what is code. For the post-processing stage of the question generation, we'll check the grammar of the question, remove meaningless question by removing duplicates, such as if two identical questions are generated from two different sentences, they will likely to be meaningless, such as the question what is good. And also we'll check the level of difficulty. And this is our rough plan for the answering part of the program. For each sentence in a wiki page, we convert it into a term frequency vector, normalize it, and construct an IDF frequency weighted matrix. And for each input question, we also convert it into a word frequency vector, normalize it, apply the IDF processing, and convert it into a quarter vector, and then use cosine similarity to find a sentence that contains the answer to the question. The cosine similarity comparison will give us the most likely sentence that contains the answer. After retrieving such sentence, we compare the sentence structure to the question. If the structure of the sentence and question match up, we'll check the words, including synonym from a word set, see if they match up as well. Then we'll go through a similar post-processing to restructure and make the answer smooth.